Hello and welcome to lesson number 5 in unit number 1, linear systems in our grade 10 academic math class. This is solving linear systems of equations using elimination. So we've tackled a first algebraic method for solving linear systems. That was substitution. Elimination is a little bit different, at least at the beginning. So now's a good time to actually pause and read through the instructions. I'm going to talk about them, but it's probably good if you've already read them once. So why don't you do that now and I'll wait. Okay, you've read them now. The idea with using elimination is that unlike substitution, where we substituted an equivalent value from one of the equations into the other by way of eliminating one of the variables, this time we are going to actually add or subtract the whole equation from the other whole equation, and we're going to eliminate one of the variables as well through the act of addition or subtraction. The trick is that we need to have the same coefficient in front of one of the variables to make this happen. So let's have a look at our first example. It's already worked out. So we have x plus y equals 8 and x minus y equals 2. What you'll notice is the coefficient in front of the x is 1 and the coefficient in front of the x is 1. So those are the same. And we have a plus 1 and a minus 1. So the coefficients, the actual numbers, never mind the signs, but the numbers in front of both variables are the same. So it doesn't matter which one we eliminate here. I've chosen to eliminate y. So in order to do that, I am going to add the whole second equation to the whole first equation. I'm going to do that successfully by lining up the x's and the y's on the left side of the equation and the coefficients on the other side of the equal side on the right. Now, strictly speaking, it doesn't matter where you put the coefficient. You could put it on the left and put the variables on the right. This is just the way I like to do it, so this is always the way I'm going to suggest that you do it. But strictly speaking, there's nothing wrong with doing it the other way. If the equations you've been given aren't in this form where you've got the x's and y's on the left side, then you're going to want to rearrange it so that it is that way. So back to this example, we have 1x plus 1x is going to give us 2x's, and we have 1y plus negative y is going to give us 0 y's. Because if we have 1y, we take away 1y, or we add 1 negative y, we end up with no y's. And then we do the same thing to the coefficients. 8 plus 2 equals 10. So what you'll notice is by adding these two equations, we've eliminated the variable y. And now we are going to solve for x as a pretty simple equation there. 2x equals 10, x equals 5. Then from here on, it's very much like substitution, where we're going to substitute x equals 5 into one of the two equations. Doesn't really matter in this case, they're both pretty straightforward. So I've chosen equation number 1. We then have x plus y equals 8. I substitute x for 5 in for x, so we've got 5 plus y equals 8. We subtract 5 from both sides to isolate y, and we end up with y equals 3. We could do a check. I just chose not to do one in this first example, and then we put up a little therefore statement on there. Therefore, the solution is 5, 3, making sure we have the x and y slotted in the correct places. And that's it. That's elimination. The rest of the examples you're going to see in this lesson are variations on what happens if. What happens if. So let's look at example B. Example B is 3x minus 2y equals negative 5, equation 1, and x minus y equals negative 2. That's equation 2. So what if you don't have two variables or a variable that has the same coefficient in front of it? It's no big deal. We're going to manipulate it to make that happen. So we're going to manipulate equation number 2, and we are going to try to eliminate, it doesn't really matter which one we do here, but I'm going to choose to eliminate y, same as last time. In order to do that, I need to get a 2 in front of this y here, so I'm going to multiply every term in this equation by 2. It will create an equivalent equation, so that's no big deal. So we have 2 times x, that's 2x, 2 times negative y is negative 2y, and 2 times negative 2 is negative 4. So that's our new equation number 3, modified number 2. I'm going to rewrite equation 1 right underneath it so that we can do that addition or subtraction, depending. And now we need to figure out exactly which of those two we're going to do. Are we going to add or subtract? So let's consider addition first. If I were to add these two equations, you would have negative 2y plus negative 2y. That'll be negative 4y. That's not what we want to do here. We want to subtract them. So let's walk through that. We have 2x minus 3x. That's going to give us negative 1x. I'll keep the 1 in there for this one. And here we have negative 2y minus negative 2y. Those two negatives bumping up, that's a positive if we were going to replace those two signs with 1. So we have negative 2y plus 2y. That's going to be 0 y's, and I'm not going to write that down. You don't have to write it down either. It's good in the first example so you can understand how we did it. Strictly speaking, you don't have to put it in there. And then you have negative 4 minus negative 5. So that'll be negative 4 plus 5. That's going to give us a 1. From here, we just have to isolate x. We're going to do that by dividing both sides by negative 1. X will then equal negative 1. All right, so from here, just like substitution, we are going to sub x equals negative 1 into one of those two original equations. I'm going to pick 2. It looks like the easiest. There's 2, so we're going to substitute in. We've got x minus y, so we have negative 1 minus y equals negative 2. We are going to isolate our variable term by transposing negative 1 over to the other side by adding 1 to both sides. That's going to give us negative y equals negative 1. And we are going to now isolate get our y to become positive by dividing both sides by negative 1. Y then will equal positive 1. Do we have room? We do have room. Let's do a check this time. So we're going to do a check. The check is going to be performed in equation number 1. And the reason is that we have used equation number 2 to find our second variable. So we are going to use number 1 to do our check. So the left side of our equation number 1 is 3x minus 2y. 3x minus 2y. And our right side is negative 5. So let's do some substitution. We have a negative 1 and a 1. So we have 3 times negative 1 minus 2 times 1. That gives us negative 3 minus 2, which is minus 5, which is what we have on the right side. So therefore, the left side equals the right side. Pop a little happy face on there, and let's get a therefore statement to sum this up. Therefore, the solution is negative 1, 1. There we go. That is our solution. This is looking really good so far. Hopefully this process or this procedure is making sense. We have 2 more examples on the next page to tackle. The second one's a bit of a bear. This one is not so bad, so let's see if we can squeeze one more in here. So what if we don't have any coefficients in front of the variables that are the same? No problem. Like in the last example, we can manipulate it by multiplying whole equations by a constant value to create an equivalent equation that does have those same coefficients out front. But what if multiplying only one equation doesn't get you the answer? So looking at this, example C, we have 3x minus 2y equals 2 and minus 10x plus 3y equals 8. So it doesn't matter what you multiply, by the first one or the second one by in isolation. We're going to need to multiply both of them. So in order to do that, let's keep going with our trend here of trying to eliminate y's. So in order to do that, I have a 2y and a 3y. If I multiply the whole first equation by 3 and the whole second equation by 2, I will have 6's in front of my y's, and from there I can work out no problem. So let's do a rewrite after multiplying our whole equation number 1 by 3. So that will be 3 times 3x is 9x minus 6y equals 6. That's new equation number 3. And we are going to have negative 20x plus 6y equals 16. And that's new equation number 4. You can see that we have those 2 coefficients in front of y that are the same. The question now becomes, do we multiply or do we subtract? Do we add or do we subtract? Because we have opposite signs, a minus 6 and a plus 6, we are going to combine or add these. So if you have 9 and negative 20, that's going to give us negative 11x. Negative 6y plus positive 6y is 0 y's. We're not going to write that down. And 6 plus 16 gives us 22. We divide both sides by negative 11. That's now x equal to negative 2. So we have found our x value. We are now going to substitute x equals negative 2 into one of our 2 original equations. The first one maybe looks a little bit smaller, so let's just do number 1. And we have 3x minus 2y. So 3 minus 2 minus 2y equals, I think it was 2. Yep. So it was 2. And now we are going to work through this. So we have 3 times negative 2 is negative 6, minus 2y equals 2. We are going to isolate our variable term by transposing negative 6 over to the other side by adding 6 to both sides. We now have negative 2y is equal to 2 plus 6, which is 8. We isolate y by dividing both sides by 2. That's going to give us y equal to negative 4. And we pop a little therefore statement on there. Therefore, the solution is negative 2, negative 4. And that is yet another example of solving by elimination. So we're going to end the first video here. We're going to come back and do that last example. The last one's fairly complicated. We get to sort of work with some fractions and things like that. That's a bit of a pain. We'll get through it. We'll see you in part 2 of this video.